6 over pi, can you use the coordinate rule?
I would have said I would bring up the.
How do you do that?
I think of that as 6 over pi x.
Yeah, right. And it's just 6 pi, right? That's like.
Oh, okay. So then it's just the derivative of x is 1, so it's just 6 over pi.
Yeah. So these say determine whether Rolle's theorem can be applied. And if it can, find the value of c and open interval such that the derivative is 0. So the first thing we got to check is, first thing is this f of 0 equal alpha pi over 6, and then is this continuous and differentiable? It is continuous and differentiable. And let's see, f of 0. If we put 0 there, we get 0. F of pi over 6. 6 over pi over 6 would be 1. Minus 4. Sine of pi over 6 is the sine of 30, which is a half. Half squared is 4. That's 1 minus 1 is 0. So Rolle's theorem applies. This is continuous, differentiable, and f of 0 equals f of pi over 6. So we take the first derivative. Derivative of 6 over pi x is 6 over pi. Minus, we're going to have to do the chain rule here, so 2 times 4 would be 8. Sine of x times the derivative of sine, which is cosine. So we want to set that equal to 0. Gary, you actually did this. What was that?
I don't.
He's so incredulous.
That's just knocking me down.
No, but I'm not saying you can't do it. I'm saying you usually don't do the homework. It's been my understanding.
Oh, that just knocked me down. I've been trying hard.
Let's see, if we set this equal to 0, this is going to be a little bit of work to solve besides. I would think we take the 6 over pi over here. It becomes negative. Divide both sides by negative 8.
See, that's what I thought.
Sine of x, cosine of x. But, yeah, so this is like 8 over 1, so we'll multiply by negative 1 over 8. So, let's see, 2 goes into 6 3 times. 3 over 4 pi. Well, the 2 negatives make it positive. See, now, I want to factor this, but you can only factor when it equals 0.
Yeah.
The original thing I couldn't think of how to factor it.
Well, what they did was.
Well, don't tell me. I'm going to assume they did the double angle identity.
Could be probably right.
So when I see sine x, cosine x, right? If this was 2 sine x, cosine x, then this would be the sine of twice the
squared
angle.
x. Sine squared x.
But see, I can't just put that 2 there. I got to also put a 2 over here. Multiply both sides by 2.
Okay, that's it.
So now this 2 goes into 4 twice, so that equals 3 over 2 pi. Hey, I don't like that pi in the denominator, though, huh? So now we got to figure out where does sine of 2x equal 3 over 2 pi?
Wow.
Don't tell me.
So where does sine equal 3 over 2 pi?
Okay, it's kind of like yeah.
We're going to take the arc sine. We're trying to figure out the angle. See, if that was 3 halves pi,
That's like 1.5, right? It's like.
yeah, but the pi's in the denominator, not the numerator.
This is on a fixed interval. Why couldn't she do like arc sine?
Yeah,
There's 0 to pi over 6, huh? Well, we can do the arc sine, but the problem is what angle gives us 3 over 2 pi? Well, like if that said 1/2, I know what angle gives us 1/2. What angle gives us square root of 3 over 2?
So what's the arc sine?
Why don't we put
2 pi over 3?
would be the cosecant. All right, this whole throwing that pi in there makes me think you can't do this without a calculator. So wait, what did they do?
It was a decimal
One half.
answer.
Yeah.
One half arc sine.
So how do you do the arc sine thing? What did that as well? I don't understand that.
The arc sine.
Well, it's basically, we need to know what angle. You know, we're trying to figure out what angle, if we took the sine, at what angle do we get 3 over 2 pi? That's not one of the ones we're supposed to have memorized.
So we actually have the arc sine, right? Since we have 2 x.
Yeah, well, I figure out, I want to know what 2x equals.
Yeah.
So I can't think of a way to do this without a calculator. So I have to come in here, I'm in radian mode, so I'll do the arc sine of 3 divided by 2 pi. So 0.4977 over 0.498.
Well, what about the 2x?
Yeah, it's right there.
Oh,
And then I get to divide both sides by 2.
I'm so excited to get to this.
So divide that by 2. 0.249. And if we think pi over 6, see pi divided by 6 is 0.52. So that's in that range. But then again, since this is 2, anytime I add pi to this, right, I have the same thing, but if I add pi to that, I go beyond that 0.52. So I'm thinking that's probably the only answer to me. Which now, if, you know, once we got to here, we had to use our calculator. If this was a calculator question, it'd be a lot easier to do it by graphing. It'd be a lot easier to come in here and go 6x divided by pi minus, in parentheses, put sine of x and square that. Take my window, let it go from 0 to pi over 6. Maybe it zoom fit. Why did that not go back down to 0?
Oh, you forgot the 4 and this?
Megan, I heard you say that first. Take anything away from the case. Yeah, but see how nice it was? We noticed there was something wrong, right? When we did it, we knew it had to go back to 0. Right? So here's where the first derivative is 0, so I use second calc, find that maximum, number 4. Just get my cursor a little to the left, that highest point, hit enter, and scoot on over to the right. Hit enter, ignore guess, and enter again. Little deja vu then. 24.2488. So really, there was no trig magically to do when we got to here. You know, if this would have been a 1/2 or square root of 3 over 2 or 1 or something like that, we could have done without a calculator. But